Hello and welcome everybody. I am the Shy Hat and we're doing PicoCTF 2024 challenges today. We are the HackerFrogs and we're going to be learning some beginners cybersecurity today. Today we're going to be learning through PicoCTF and let me just grab the link for you right now. So if you want to join in with us, you'll need a registered account over at PicoCTF.org, but that is a free service, so it shouldn't be too difficult to access. All right, so after you've logged into your PicoCTF account, you'll want to navigate to the link that I just left in the chat. So today we're doing part 2 of PicoCTF 2024 challenges. Last time we solved all the way from Super SSH all up until the verified challenge over here. Okay, so first time chatter, GX000, I just like to watch. That's perfectly fine as well. If you can get some entertainment and maybe some learning from watching us solve these challenges, that is just fine. Okay, so we're going to be using the PicoCTF web shell to solve most of these challenges. So I'm going to do a quick tutorial on how to open the PicoCTF web shell. So from the PicoCTF web page, you'll want to click on this button right here, which is labeled web shell. So click on that. And from there, we're going to want to put this in its own browser tab. And you can do that by just clicking on this right here, pop out web shell terminal. Click on that button. And the web shell will be put in its own browser tab, which is much more convenient for us. From here, you're going to need your PicoCTF username and your password. So let me just grab that from my password manager. Let's see, GX000 says trippy cursor. Well, I'm trying to let everybody know where the cursor is so people know what I'm pointing at, so that's why the cursor is that way. So let me grab my password. So I am the Shy Hat and my password is this. Remember, when you paste in your password or type in your password on a Linux system, you're not going to see the password, and that's by design. So it's just going to be hidden while you type in the password. Okay, so after you've done that, you'll have access to the web shell. So GX000 says, so what's your password? Well, it's Control-Shift-V. That's what I use to put in my password. Thank you very much. I'm here all week. Okay, so once you've logged into the web shell, you will have access to a Linux virtual machine, which you can use to solve challenges. And I very much recommend that you make a separate folder for each one of these challenges, just so you can keep all the files separated away from each other, and so that things don't look really messy after a while. Okay, so now that we've completed opening our PicoCTF web shell, I'm going to give you a hint, a little tip on how to keep the web shell open for more than the 15 minutes that you're allotted. So it says that idle sessions will automatically be logged out after 15 minutes, but you can get around that by entering any text editor. So I like to do nano, and then while we're in nano, we're not going to be kicked out. But in the meantime, let's go over to the first of our challenges for today. And we also have VM Smith 01 heart. GX000 says Vim for life. Well, I agree that Vim is a very powerful text editor, but we're using Nano here because Nano is a lot more simple for newbies who wanted to get into this. So VM Smith 01 says heart. Welcome to the chat, VM Smith 01. I hope you can learn with us today. So if you haven't, please log into the PicoCTF website and then log into your web shell. And then we're going to be solving the first challenge for tonight. It's called Blame Game. So this is Blame Game. I will paste the link for this challenge in the chat. GX00 says, fun fact, since you're working on PicoCTF, Nano is a fork of a text editor called Pico. I didn't know that. Thank you very much for the knowledge. Okay, so let's start the challenge. Blame game. This is a general skills challenge, and it is part of the Git series of challenges for this year's general skills challenges. So someone's commits seem to be preventing the program from working. Who is it? You can download the challenge files here. Okay, so we have a link that we can use to download the Git repository, and I'll leave that in the chat as well. But how you would do it inside of the web shell, let me get out of here. So you can exit from Nano by using Control-X to get out of there, and we'll just go into our, what was this challenge called again? It was called Blame Game. Okay, so let's go into our Blame Game directory. So inside of Blame Game, I'm going to create a temporary directory just so we can work inside of that. So we would do the wget command and then paste in the URL for the challenge to download the file. So we download the file with wget, and then we unzip the file by just using the unzip command. So it's unzip challenge.zip. I'm going to say none. Hold on. Okay, we need to go into the temp directory. Sorry about that. Okay, so we're going to download it again, and then we're going to unzip the file. So this unzips a zip repository, and we're going to need to move into the drop-in directory in order to access the Git repository. So we cd into drop-in, and from here we can use all of our Git commands. So let's see what's in this directory. So there's a message.py Python file. So we can cap that out, message.py. And this is an incomplete Python statement, so this is not going to run because there's no closing bracket over here. So what we need to do is we need to find out where this all went wrong. Let me take a look at my notes. So this is general blame game. Okay, so what we can do inside of the Git program. So Git is a collaborative development software. So what we can do is we can git log, do the git log command in order to get the past commits, and we can also grep for a particular message. And in this case, it's going to be print hello world, and this is, yeah, so it was just like this. And then we can search inside of message.py. No, wait. Okay, so we can just grep for this. So we grep for this message, and we'll try to find this inside of the log. It seems that if I've done something incorrect. So did I? So, okay, so we can do this, the man. Where is the grep? The -s is supposed to be the grep. But the manual way of doing this is to do the git log, which shows all of the commits over here, and you can scroll all the way to the bottom, which is kind of tedious. And all the way at the beginning of the history for this particular repository, it'll show you that first the secret project was created, and then the optimized file size of prod code was done over here, and this is the commit that changed the code to where it doesn't work anymore. So this is the flag for this particular challenge. We can use this and submit it over at the challenge window over here inside of this field right here. We can click on submit flag. And if we haven't done so already, we can also click on the thumbs up button over here to rate this positively and to give the challenge makers some love. Okay, so I could have sworn that there was a way to grep it out. I think I did it incorrectly. I'm gonna ask ChatGPT. So using Git, how can we grep for a specific string in the log file? Okay, so it seems that we might be able to use grep for a string like this. So let's try this out. And the search string is going to be print hello world. I guess we could just search for print and it should show up. Okay, it doesn't want to, it's not cooperating with us right now. But we're going to move on because we have quite a few challenges to move through tonight. But if you manage to get through this one and submit the flag, please type in, who are you calling a Git into chat, and then add some smiley faces if you like. Okay, so we're going to move on to our next challenge, which is called collaborative development. This is another Git related challenge, and it's located right here. So I'm going to paste the link for that in the chat for you. Okay, so in collaborative development, this says here, my team has been working very hard on new features for our flag printing program. I wonder how they'll work together. You can download the challenge files here. Okay, so and it has a link for the challenge file. I'll paste that in the chat for everybody. And then we will move out of the current directory, and then we'll move into our collaborative development directory. I'll make a new temporary directory in here and then move into it. And then I will download the file, and then we will unzip the file. Okay, so these are all in the drop-in directory, and in the drop-in directory there's a flag.py file. We could try running it with Python, and it just says printing the flag. Okay, so let's take a look at my notes for this particular challenge. Okay, so in this case, we can take a look at the different branches of a Git repository by using the command git branch -a. So this is going to show the different branches of the project. And it says here that there's a main branch, and then there's feature part 3, feature part 2, and feature part 1. Okay, so what we can do is we can git log and retrieve the commits for these particular branches. So the first thing we're going to want to do is we're going to want to git log, and then it's feature part 1, part -1. So when we git log this, we see add part 1, and we see a init flag printer. So what we can do is we can get the particular details of a commit by copying the commit number right here, and then we can use the git show command. So it's git show, and then the git code, for that commit, and it's going to show us what was modified inside of that commit. So in this case, it says printing the flag, print PicoCTF teamwork, and then end. So what we can tell is from the prefix over here, PicoCTF, is that this is part of a flag, and it's probably going to be in 3 parts because there are 3 parts in this particular challenge. We can copy this, and then we can paste it somewhere for our reference, and then we're going to exit out of here. So it's going to be :Q to quit out. It's just like how it's done inside of Vim, in fact. Okay, so we need to repeat the process 2 more times for feature part 1 and feature part 3. So we're going to git log feature part 2 rather, and that shows us that the commit we want to investigate is this right here for feature part 2. And then we'll get out of here by doing :Q, and then we're going to git show. And this is going to show us the commit for feature part 2. And that shows this middle part right here of the flag. So we're just going to copy that. And then we're going to paste it somewhere for our reference, and then get out of here with :Q. And then we're going to finish off by taking a look at feature/part 3. And that is, the commit number is this. I'm not too sure what to call it, whether or not it's a commit code or a commit number or a commit something else. But that's what it is. I actually don't know too much about working inside of Git, but what we hackers do is we learn the technology that is presented in front of us. I assume that people who are developers already know this stuff, but I kind of had to learn it on the fly as I was going through these challenges. So let's show feature part 3. It's called the commit hash. Oh right, that's correct. It is a hexadecimal hash. Thank you very much, GX000. Okay, so we have the last part of the flag right here, which is this. And I'm going to copy that and then paste it along with our other parts. So I'm going to paste the flag into the chat, but I'm going to warn you that the flag is not going to be the same for every user, and every user has a slightly different flag, mostly in the hexadecimal portion at the end of the flag. So this flag isn't necessarily going to work for you. Okay, so now that we have our flag, we can go back to collaborative development and we can paste in the answer and submit it. And in collaborative development, we can click on the rate positive button so we can show some love, and that's done. Okay, so GX000 says, "Damn it, I can't copy paste your work and get all the credit." Well, I mean, who's learning? Who's learning if you just copy pasting somebody else's flag? I don't answer that. I don't really want to know. All right, so that's collaborative development done. If you finish collaborative development with us, please type in teamwork and some smiley faces. If you're on Twitch, the official HackerFrogs emote is either OSFrog or HackerMans. Just for your reference. Okay, so let's move on to the next challenge. So we'll go on to page 2, and this is the challenge called bin hexa. So bin hexa right here, I'm going to paste in the link for this. Whoops. Okay, so bin hexa is a general skills challenge. It asks how well can you perform basic binary operations. Additional details will be available after launching your challenge instance. Okay, so a lot of challenges inside of PicoCTF are attached to VMs. So VMs that host the CTF infrastructure. So you can click on this button right here to launch your own VM, which is associated with this challenge. And it says we can start searching for the flag here at this particular command, which uses netcat. Okay, so before we copy this, and this is probably not going to work for... Actually, you could probably use this yourself if you really wanted to. So I'll just paste this in and paste this into chat for you people. Okay. So let me go into my directory for this. This is called bin-hexa. Okay, so you people meaning you good HackerFrogs out there is what I'm trying to say. So I'm trying to avoid saying you guys because that's not very inclusive. So I'm defaulting to saying you people. Or maybe I should say you frogs, or you HackerFrogs. Alright, so if we were to use this particular command right here, it says, your task is to perform unique operations in the given order and find the final result in hexadecimal that yields a flag. Okay, we're given two binary numbers over here, so this binary number and this binary number. And we're going to get some different questions that want us to perform different mathematical operations with these numbers. So in this case, operation 1 is going to be multiplication. Perform the operation on binary number 1 and 2 and enter the binary result. Okay, so what we could do is we could copy paste each of these numbers into our binary calculator and do the math that way, but that's a bit slow, and I've designed a little script to do the same. So I've quit out of there, and I created this. It took me a really long time to create this this script over here that connects to the server and does all the mathematical operations. It's called Connect and Math, and it's a really involved script over here that takes a bunch of different. Where is it? That takes a bunch of binary numbers and does and keeps track of which operation is happening. We have to do a bitwise operation. We have to do a bitwise AND operation. We have to do a bitwise OR. We have to use a bit addition. Let's see. GX000 says, you don't know binary? I don't tend to work inside of binary as far as mathematics are concerned. That's why I wrote a program to do it for me. There's a left bit shift and a right bit shift, and there's binary multiplication. So depending on what is what appears, I've got this this script which connects to the server and then records the output, and then does and then sends answers to the server, and gets the answer that way. So I'm going to share the script with you all. It's in the HackerFrogs GitHub repository. So it's GitHub. I'm just teasing. I can be a bit of a troll. No worries, no worries. I'll tell you if I'm actually offended. Hopefully I'm not actually offended at any point. All right, so let's see. Was this after school? No, I'm not looking for after school. I'm looking for... I'm not looking for HackerFrogs either. I'm looking for CTF documents, okay. So CTF documents, PicoCTF, and this is the general, and we're doing bin-hexa. So I'm going to copy the link for that. Do you recognize who I am? You look very familiar. Okay, so I thought you spelled your name with the J, but I guess you can also spell it with the G. All right, so that's a link, and that contains the script that I'm using. If you want to try it out for yourself, go ahead. You're going to have to replace you're going to have to go in and replace the port number. So at the bottom of the script here, there's a host and there's a port number, and you're probably going to need to replace the port number because it's different every time. I do spell it with a G. Well, good to hear about that. And I'm glad you can join us because we're not doing our stream at an hour where everybody's working, like I am usually. Okay, so I paste in the port over here, and then I'm going to exit and save. And when I run the script, it's going to do all the math for us. So Python connected math. And so we see here, it gives us the binary numbers, and then it gives us the bitwise AND operation, and then I think that's the left shift. Is that the right shift? That's the right shift, and then the left shift, and then the addition, the multiplication, and the OR operation, and then finally we get the answer in hexadecimal, and we get the flag over here. Okay, so if you finished this, whether or not you use my script, please type in bits and bytes, and then some smileys and some hackermans, whatever you like. Okay, so I'm pretty sure that this flag is also unique to each user, so you can't necessarily use my flag. I'll paste it in just for fun if you want to try it out. Okay, and so back at bin hexa, you can paste in the flag over here, click submit, and you're done. All right, so that's bin hexa. The next challenge is can you see? So this is the can you see challenge. It's part of the forensics category over here, and I will provide the link for everybody. I hope some people are following along, but if not, I'm going to be splitting up this live stream, and I'm going to be posting it up on YouTube, and you can catch it there in maybe a week or so. All right, so can you see? The description says, how about some hide and seek? Download this file here. All right, so I will copy the link and give it to everybody in chat if you need it, and then we will move on over to our can you see directory. Oops. Okay, so this was this is a zip file. Okay, so I'm going to move into a temporary directory, and I'm going to download the file, and then I'm going to unzip the file. Okay, so here we have the UK, I guess, unknown reality JPEG over here. This is a basic forensics, a basic image forensics challenge, which means that we can use tools such as strings. So usually I like to run strings with the UKN, with the -10 command, where we can only return text strings that are 10 characters in length or more. Oh, it should be strings with an S. Okay. So we might look into here to look for an answer. It doesn't look like there's any answer over here. The other tool that we often use inside of beginners picture forensics challenges is the exif tool command. So exif tool is going to show us a lot of metadata about our particular image file. So what was the name of that file again? Let me take a look. So it was called UKN reality, right? Okay. So exif tool, and then UKN reality.jpg. And what this tool does is it shows us a lot of metadata about this image file. GX, yes, let's use tab autocomplete. So tab autocomplete lets you autocomplete file names if there are not so many choices with the same spelling inside of the directory. So we see here there's a lot of different information, metadata information about this file, stuff like file size and access modification time, file permissions, file type. But interestingly here, there's this particular string inside of the attribution URL, and I'm sure somebody in chat can tell us what kind of encoding this could potentially be. But if you don't know, you could go to ChatGPT and you could ask, what kind of encoding or encryption is this? And then paste in the string. And ChatGPT says the string appears to be base64 encoded over here. And base64 is an encoding scheme which is used to transform data into alphanumeric strings. And it's very good for transferring binary files or image files across data networks. Computer networks. Because sometimes you have to pre-package something before you move it somewhere else. So what we can do, if we know that this is a base64 string, is that we can copy it, and then we can use the echo command. So I like to do echo-n to make sure that there's no new line character included in this output, and then paste in the string, and then we're going to pipe it by using the pipe character over here into base64-d, which does the decode operation. No worries, GX000. Sometimes I get my encoding strings mixed up too. Okay, and so after we do that, this string is decoded using the base64 codec, and it returns the flag right here. So we can copy this, and we can use this as the answer for the challenge over here. Hold on, I'm getting a message. I just need to answer it real fast. But thank you very much, everybody. So if you manage to solve this particular challenge, can you see? Please paste in the flag and click on submit, and then it says that you solved the challenge correctly. Okay, if you have not already done so, please click on the thumbs up button on the challenge. All right, so that is can you see done. I'm going to skip over this cryptography challenge, custom encryption. I know what the answer is, but I can't explain the answer very well, and if I can't explain how to do a challenge, I'm not going to go over it in this stream, because I feel like I should be able to explain the things that I'm doing. So we're going to move to this next challenge over here called Intro to Burp. So this is a web exploitation challenge. It's called Intro to Burp. Unfortunately, we can't solve this challenge using our web shell. I'm going to nano over here just so that I don't get kicked out while I'm solving this challenge. So it says, additional details will be available after launching your challenge instance. So we're going to click on this button right here to launch our challenge instance. It's going to take just a second. One great thing about PicoCTF challenges is that the VMs initialize very quickly, so we're not waiting around for a long time. So it says, now it says, try here to find the flag. So I'm going to copy this link for everybody. I think everybody can use my challenge, or maybe you should be using your own challenges, because the flag might be individualized. So you should probably not use my link, and you should use your own link by creating your own virtual machine. but I'm going to go into here and it says registration. Okay, so full name, you can put anything inside of this web page. But what we really should be doing is we shouldn't be solving the challenge here. We should be solving the challenge inside of Burp Suite, because the challenge is called Intro to Burp, and Burp Suite is a very powerful piece of it's a very powerful web application proxy tool. I guess proxy, and it's also a vulnerability scanner, and it does a lot of other stuff. But what you're going to need to do is you're going to need to either have access to Burp Suite on your host machine, your regular OS, or you're going to have to use Kali Linux, it's also a man-in-the-middle device, correct? So if you're using Kali Linux, you can go over here and you can in the search screen you can search for burp, and there'll be one button over here which you can press on, and Burp Suite Community Edition, which is installed on Kali Linux, will start up. So when you reach this screen, you're just going to want to click on Next and then Start Burp. GX says, not to be confused with Man in the Mirror. That was a Michael Jackson song, wasn't it? That's kind of a callback, isn't it? Okay, so after you've started up Burp, what you want to do is you want to click on the Proxy tab right here. So Proxy is next to Dashboard and then Target and then Proxy. And from here, you're going to want to make sure that Intercept is off. So in some versions of Burp, Intercept is set to on. If this is on, it's going to mess up your workflow. So you're going to have to make sure that the Intercept is switched to off. You can switch it on and you can switch it off. And then you want to click on this button, which is called Open Browser. So Open Browser is going to open a Burp Suite connected web browser. So Burp Suite has its own Chromium browser, which you can access from inside of Burp Suite. And the Burp Suite browser is much easier to work with than working with proxies, web browser proxy programs, which was the traditional method of using Burp up until maybe a few years ago. But now Burp Suite has its own built-in browser, which is connected to Burp Suite, which is much more convenient. So the web browser does take a little while to initialize. GX, do you work with Burp Suite very often? It is a very convenient piece of software for working with web applications, and in particular web application testing. And in fact, if you become a professional web app security tester, this is just about the industry standard as far as software is concerned. You'll be working every day inside of Burp Suite. Okay, so this is taking just a little bit. I think I'm going to grab my looks like the CPU is maxing out on my Kali machine over here. So I'm just gonna have to wait this out. But in the meantime, while we wait, how many people here have access to Burp Suite or a Kali Linux virtual machine? So if you do, please type in chat, maybe give us some smileys and say, yes, I do. Just like this. GX says, I'm sure I have it installed on one of my many devices. Well, I'm sure, I'm absolutely sure you do. Okay, so it looks like looks like I'm having some technical difficulties. The Burp Suite browser seems to be hanging my system. Okay, so what I'm going to do is I'm going to turn off my virtual machine over here, and then I'm going to try rebooting it. I'm doing it live on air, everybody. Okay, so yeah, it's become unresponsive. So I'm going to get out of here, power off the machine, and then I'm going to restart my virtual machine. Sorry for the technical difficulty, everyone. But how's everybody doing on this fine Friday evening? I hope everybody is having a good time. I know I am. I'm streaming and hopefully not doing too bad a job. Okay, so let's try spinning up Burp Suite again. Let's see. It's VirtualBox on Windows. It is to be expected, honestly. Well, I'm trying. Okay, so I haven't had any troubles up until now. I think it's because the virtual machine had been running for a bit too long. Sent too many messages automated, deleted everything. Oh. Were you spamming my chat? Okay. All right. So we go to proxy. We make sure that intercept is off. We open the browser, and hopefully it doesn't. Okay. So now this time it works. So this time it works. We're in our port switcher page right here. I'm going to grab the website over here, and then we're going to go back to the Burp Suite browser and paste in the URL. 2 messages in quick succession. You know what? I really should just modify the bot mode to be more permissive. Okay, so inside of the Burp browser, what we can do is we can just do test for everything on this page, and so everything is test, and then click on register. And on this page, it says 2FA authentication. So what we're going to need to do is we're going to send a test over here as well. Okay, and it says invalid OTP. So how do we get past the OTP? Well, I'm not ashamed of using some hints on the challenges, especially if they're just given to me. And in this case, there are 2 hints over here. Hint number 1 is try using Burp Suite to intercept request to capture the flag. And hint number 2 is try mangling the request. Maybe their server-side code doesn't handle malformed requests very well. Okay, so this is the key to solving this challenge. So back inside of, wait, we're not going to be using the Burp browser anymore. Instead, we're going to go back to Burp Suite. And inside of Burp Suite, there's inside of proxy, there's a tab called HTTP history right here. Click on that, and it's going to. These are all of the requests that we sent through the Burp browser. So we can click on the number sign over here. So the very last request that we sent was this post request to dashboard. So we can click on that, and we see here this is the post HTTP request to the OTP, where we were trying to send the OTP request to to the server. And you note here that it says OTP equals test. So this is what we sent to the browser. What we're going to do is we're going to start playing around with this. So we can do that by right-clicking on this window, and we can send it to the repeater, which is this option right here after you right-click. Otherwise, you can use the Control+R keyboard shortcut. So click on that, and then we can go back up to here, the repeater tab. So it's target, proxy, intruder, and then repeater. So click on repeater. So over here inside of the response, so we can send this to just get a baseline for what happens here. So if we send this message over here as it is, it's going to say the response is going to be invalid OTP. And we can actually render this inside of this response portion of the window to make it look like a web browser by clicking on from pretty to raw to hex to render over here. And it just says invalid OTP, that's the response. So here what we're trying to do is we're trying to mangle the request. So instead of OTP equals test, we can just say, we can do anything else, garbage equals test, and then send that. And so the web app lets us bypass the OTP because we're not sending the correct information over here. All right, so it says, welcome test, you successfully bypassed the OTP request. Your flag is this, and this is the way we finish this challenge. So I'm going to go back to pretty over here, and this is going to let me copy the flag over here, copy that, and then go back to the challenge webpage. So intro to burp, we can paste in the flag over here, and then click submit flag. Okay, so that's intro to burp done. So don't forget to click on the thumbs up. This is not a very well rated challenge. I thought it was okay, but click on rate positive if you appreciate the challenge. And then we're going to move on to our next challenge. So the next challenge, oh, sorry. So if you happen to finish this challenge, intro to burp, please type in, sorry I burped, and then smileys, just so I know that everybody's following along. If you are following along, if you're not, that's fine. And we're gonna move on to our next challenge. And the next challenge is called Packer. So this is the Packer challenge. It's part of the reverse engineering category, and I'm going to provide the link in the chat for you all. GX says, sorry, I farted. Oh. Well, I mean, that's kind of, well, it's somewhat similar, maybe. All right, so this is the Packer challenge. It says, reverse this Linux executable question mark, and there's a link to a binary executable file. I'll leave the link to the binary executable file for chat. Okay, and we're going to, inside of the web shell, oh, I have to do my web shell again. Hold on. Okay, and I'm going to grab my password. Hold on. Okay, and from here, Control V. Control V is my password, correct? No, it's Control Shift V. All right, so I'm going to go into what this is called, Packer. So this is the Packer challenge. There's nothing in here. Is there really nothing in here? Okay. All right, so I'm going to copy the binary executable file over. And then I'm going to use the wget command to download it. And it is this file right here called out. So what we need to do is we need to make this binary executable one. We need to make this file binary executable because we can't execute it as is. So chmod plus x and then out, which is the name of the file. And then when we look at it next, we see that it has become executable. So we could try just running this file just like this. Enter the password to unlock this file. I don't know. Access denied. Okay, so in fact, because this is the first reverse engineering challenge in this event, the method of solving this is actually very easy. We can use our good old friend strings on the file, and we can give it strings 10, and it says this file is packed with the UPX executable packer, okay, and then has a little URL over here. So the thing is that this has something to do with the name of the challenge as well. So this challenge is called Packer, and what we know about what is it called? Zipping, compressing. So compressing binary executable files after you've compiled it, it reduces the size of the binary executable file. But at the same time, it also makes it harder to conduct forensics on, because it changes the strings and the symbols that were used to compile the file. So if we know that this was packed with the UPX executable packer, we can unpack it using the same software, and that's going to let us see more information inside of this binary executable file. So we can ask our good friend ChatGPT, how do we uncompress a file using the UPX program on Linux? Okay, and it gives us the syntax over here, UPX-D file name. So let's copy that and then go over here. We can paste in that command, and we can replace file name with the name of our binary, which is out. So UPX-depress out, decompress rather. Okay, so after that, we can run strings on it again. And we see there's a lot more. Okay, there's a lot of stuff there. Hold on. So what we're going to do is we're just going to grab the beginning of the output there, and then we're going to pipe this into the head command. Okay. All right, so that didn't really help too much. Okay, what we're going to do is we're going to grep for the flag. So because there's a flag in here, we can grep for it. So we're going to grep the term flag here. And it says password correct, please see flag, this over here. So there's this long string. And what kind of encoding or encryption do you think this might be? So I can tell you this is not base64. This is not the type of encoding or encryption that we're dealing with. In this case, we're dealing with hex representation. So it's hex representation of ASCII code, and what we can do is we can use a handy-dandy website to translate this for us. There's this one website called Rapid Tables, and they have something called a hex to ASCII string converter. So we paste in our hexadecimal, and it's going to output ASCII for us, which is what regular computers speak. So we paste in our hexadecimal code over here, and then it's going to translate it to text. So we click on convert, and this is the result. It's a whole flag. So we can copy that. Actually, you know what? I'm going to give everybody in chat the website that I'm using over here, so you can try it out yourself. Okay, so what happened there? So this binary over here had a string inside of the binary that told us what the flag was, but the flag was encoded in hexadecimal. hexadecimal representation of ASCII code. So we took the ASCII code over the hexadecimal code over here, and then we fed it into this website over here that turns hexadecimal code into ASCII. And by doing that, we were able to get the flag. So copy the flag and go back to the challenge page, paste in the flag, and click on Submit Flag. Okay, and if you haven't already, click on Thumbs Up. Alright, so everybody, if you managed to solve that challenge, please type pack and unpack in the chat. And we're going to move on to our next challenge, which is a forensics challenge called Secret of the Polyglot. So, Secret of the Polyglot Forensics Challenge. The description says, the Network Operations Center of your local institution picked up a suspicious file. They're getting conflicting information on what type of file it is. They brought you in as an external expert to examine the file. Can you extract all the information from this strange file? Download the suspicious file here. And there's a link. I'm going to copy the link and provide it to chat. Okay, so unfortunately, according to the tags over here, we can't solve this challenge with the PicoCTF web shell. So I'm going to put the web shell on pause. And then I'm going to just use my regular old Kali terminal over here. So I'm going to make this nice and big. So I'm going to create another terminal window. Okay, so hopefully you can see this. Okay, so I'm going to move into a temporary directory over here inside of my Kali virtual machine, and then I'm going to use wget to download the challenge file over here, which is flag 2 of 2 final.pdf. So if this is a PDF, and we see that is right here. So it's right here. What we can do inside of Linux to open this file from the command line is you can use the xdg open command. So it's going to be xdg open, and then we're going to supply the name of the file, which is flag 2 of 2 final.pdf. Alright, so if we open this, this is a bit small, so I'm going to see if I can make it bigger. So it's basically just an image file, rather a PDF file, and inside of the PDF file there's this portion right here. This is the second half of the flag. So you might be able to tell that it's a flag because there's a curly bracket at the end over here. So just know that we're going to need this as well as the first part of the flag in order to solve the challenge. So we can copy this and then we can keep it somewhere. So I'm going to keep it on one of my notepad instances, and then I'm going to get out of here. So another thing we can do with this PDF file is we can use the exiftool command to take a look at the metadata for this particular file. So inside the metadata here, it's going to tell us a lot of metadata information about this file as usual, as we expect it to. But also, one thing we have to note in here is that there's a warning over here. So warning minor, trailer data after PNG IND chunk. So what we could do is we could ask ChatGPT what this means. So I already know what it means, but this is an example of how we could use ChatGPT to help us out with these challenges. So using exiftool, we got the following error message. What does it mean? Okay, and then we supply this to the to ChatGPT, So it says, in the context of exif tool, this warning suggests that there's some additional data in the file that isn't part of the standard PNG structure. This extra data could be benign or potentially harmful depending on the source and intent. And in fact, I've seen this kind of warning message inside of CTF challenges before in regards to image files, and it usually means that there's some sort of embedded file associated with this. So if we wanted to extract an embedded file that's inside of any other type of file, we could use the foremost command. So FOREMOST, and then the name of the file. And what this program is going to do is that it's going to extract the embedded file for us. So it says processing and then all, I guess, which what this means. So we LSLA to see what's in here, and the foremost program is going to create this output directory over here, which is all the stuff that it extracted from the file just now. So we can move into that directory. So cd output, and in here there's an additional PNG directory. So we can move into that PNG directory, and we see that there's a PNG file in here. So we could try using strings or exif tool on this as well, but the simple answer to this particular challenge is just to open this file. So once again, we can do xeg open, and then we supply the name of this particular file, and then I'm going to make this much bigger so you can see. So this looks like a flag. So PicoCTF, curly bracket F1, U3, and Z. Okay, so I'm going to manually copy that over because I can't copy it with the mouse, unfortunate. And then I'm going to start typing in F1, U3, and 7 underscore. Okay, and then I'll paste in this this particular flag in the chat. I don't know if you're going to be able to use it or not, but in LeetSpeak it says fluent in PNG and PDF is the message over here. So I'm going to use this as my flag. I'm going to go back to the PicoCTF challenge webpage, and then I'm going to paste in the flag, submit, and that is Secret of the Polyglot done. Okay, so if you finish that particular challenge, please type in multiple languages and then some smiley faces, because polyglot is a word that means that you know multiple languages. GX says, I've never heard of Foremost that looks like a useful forensics tool. It's a much more useful forensic tool than the other program that's used to extract embedded files, which is called binwalk. I find that Foremost is a lot easier to use. It's just plug and play basically. So I find it a lot easier to work with. Okay, so that challenge is done, and we're going to move on to this this very simple web exploitation challenge called Unminify. So Unminify over here. I will copy the link for you. Okay, and the challenge says, I don't like scrolling down to read the code of my website, so I've squished it. As a bonus, my pages load faster. Additional challenges will be available after launching your challenge instance. Okay, so we can click on Launch Instance to start our virtual machine for this particular challenge. And then it says, browse here and find the flag. So I suggest you use your own challenge instance because the flag might be individualized, and I don't want you to copy my flag and then not be able to finish the challenge. So click there, put it in a new tab, and it says, welcome to my flag distribution website. If you're reading this, your browser has successfully received the flag. I just deliver flags. I don't know how to read them. Okay, so what can we do to? Can anybody in chat tell me what we can do to start investigating this webpage? Inspect the source, says GX. That's exactly it. Okay, so we can start inspecting the source. We can either right-click the page and click on View Page Source, or we can use the keyboard shortcut, which is Control-U. So I'm going to click on View the Source, and this text is really small. So we can see here that that this is a very lengthy piece of code. I'm going to make this smaller. I just deliver flags. Okay, so the key to this, I'm not actually sure what they're trying to teach inside of this particular challenge, but the flag is kind of sitting here in the code, and I guess it's trying to teach us that that we should look at code that has been that hasn't been, how do you say, compressed to find more information. So you can just find it here. It's pretty close to the end of the line. So copy this, and this is all there is to this challenge. So go back to the challenge page and paste in your flag and click on Submit. Okay. All right, so if you managed to finish that one, so please type in unmini-me and then some smileys. Okay. All right, so that's that challenge in the books, and the next challenge is going to be this binary exploitation challenge called Format String. So this is called Format String 1, and this is a bit more complicated than some of the other challenges we did tonight. So this is called Format String 1. It says, Patrick and SpongeBob were really happy with those orders you made for them, but now they're curious about the secret menu. Find it, and along the way, maybe you'll find something else of interest. So download the binary here, and download the source code here. GX says, got a split. Good night and have fun with the rest of your stream. Well, thank you very much for coming and chatting along with us. We'll see you next time. Okay, so you can download the binary here. I'm going to copy the links out to chat to everybody who's following along with us. Okay, and for this we're going to be working inside of our PicoCTF web shell. So I'm going to move over to the web shell, and okay, so I'm going to move into the directory called format string 1, and I'm going to create a temp directory for this. And then I'm going to start downloading the files. Okay, so I'm going to make the format string file, the format 1 binary file executable by using the chmod +x and then format string 1, just so we can run the program. So inside of binary exploitation files, there's a way for us to exploit the binary of the file in order to retrieve the value of a flag file, and that's our goal for these binary exploitation files. So what I'm going to do, because they've generously given us the source code for this particular executable file, is I'm going to nano into it. Just take a look at what's inside of this file. So this is a C program, and you can tell because of the headers at the top include this, and you can see that the format of this particular code matches what C usually does. So there are these variables, buff secret1, flag secret2, and we can see in here that some files are being opened. So there's secretmenu1.txt, and there's flag.txt, and there's secretmenu item2.txt. Okay, so what we need to do is we need to create these files inside of this directory in order to run the binary properly. So that's what I'm going to do right now. So we're going to do some echo commands to create these files. It's a secret. Let me take a look at my notes. So this is binary exploitation, and it is format string 1. Oh, that doesn't tell me what the name of the file is. Okay, so it's secret menu item. All right. So we're going to echo, and we're going to echo into secret menu item 2.txt, and I'm going to just put secret2 inside of this file. And I'm going to create secret1 inside of a file called secret menu item 1. And then I'm going to create a flag.txt file. So it's echo flag get into flag.txt. Okay, so these are the secret messages we're trying to get out of the program. So let's go back to nano and see if there's anything suspicious about this particular program code. So the one interesting thing about this program here is that it uses a printf function over here. A printf function over here that references our user input, but it doesn't necessarily check if the user input is in the correct format or not. So this is what we're doing here is we're taking advantage of what's called a format string exploit, in which we're able to print out stuff in the memory by referencing it inside of our user input. So let me explain. So because the printf function over here is not checking whether or not what we're putting as input is a string or not, we could potentially put variable names inside of our input, and it's going to print out variable names. Well, not necessarily variable names, but it's going to print out stuff at different memory locations, and I'm going to show you how. Okay, so we're going to exit out of here, and what we're going to do is we're going to run this program. So format string 1, we're going to run this. So it says, give me your order and I'll read it back to you. So I got some help from another teammate of mine who also did the PicoCTF 2024 event with me. And what we're going to do is we're going to feed the input over here a bunch of %Ps. So %P refers to a memory address. So it's a memory address pointer, and it's a format string. And so what's going to happen when we give this to the program is that it's going to give us the values of a bunch of memory addresses. So we're going to run this. And it shows us a bunch of different memory addresses, a bunch of contents of memory addresses. And some of this is going to be useful and some of it isn't. So what we're going to do is we're going to copy this. And then we're going to go over to our good, this handy dandy website called CyberChef. And CyberChef is a website where we can do all sorts of transformations to different input. So we can apply encoding or hashing and all sorts of other stuff. So what I suspect over here, so I pasted in the input, and what I suspect over here is that we might be able to get the contents of the secret item text files as well as the contents of the flag text file over here. So we paste this in here, and in C, it usually does hexadecimal code to ASCII code. So I'm going to apply this filter over here. It's going to be from hex. It converts a hexadecimal byte string into back to its raw value. So I'm going to apply this. Okay, and then because the bytes are usually fed into the string backwards, we're going to also apply another filter over here called reverse, which reverses the byte order. Okay, and we see secret 2 is over here because that was part of the file. That was part of the value of the secret 2 text file, right? So we see that we've gotten some different values from the program memory space in here. So what we can do is we can apply this to the actual challenge, and the actual challenge lives up in the cloud. We are going to go to launch instance, click on this. Okay, and it says connect to the challenge instance here. So this is going to be different for everybody. So I recommend that you start up your own instance so that you don't get a wrong flag. So we're going to copy this, and then we're going to go back to the web shell, and we're going to execute this command to access the server with the program. And it says give me order, and I'll read it back to you again. And we're going to recopy that series of P format strings. So P stands for pointer, so it's going to give us the contents of these memory addresses. So they're going to be different from these ones because the contents of those files, the secret item 1 and 2 and the flag file is going to be different. What you need to do is we're going to copy this. Oops, copy this, copy all of this, and then we're going to go back to CyberChef. Okay, so hold on. I'm going to copy the URL for CyberChef for everybody, just in case you need it. Okay, so we see inside of here, there's a bunch of garbage information, but there's also what looks like a flag. So it says PicoCTF, and then, but it seems like the order of the flag is kind of mixed up. So what I'm going to do is I'm going to start deleting some of these memory addresses. Okay, so that seems to have taken stuff off the end. So we're going to take stuff off the beginning by doing okay. So slowly we're going to trim out everything that doesn't belong. I think we can get rid of this. we can get rid of some of the stuff at the beginning. Maybe this. Hold on, I think I need to get rid of this null stuff. Okay, I think this is all we can do before it starts getting weird. So I'm going to copy this beginning of the flag right here, and I'm going to copy this. Whoops. And I'm going to start reassembling this instead of my notepad. Okay, I think I'm pasting what I think the flag is in chat. And I'm going to try out this flag in the challenge itself. So format string 1, go back to the, and try to submit this flag. And it says the flag is incorrect. Okay, so I must have done something incorrectly there, but I think I think this is the way you're looking for the flag. But I seem to have deleted a little bit too much of the input over here. All right, so I might come back to this later, but there are a couple more challenges I want to get through before we finish off tonight. So let's move on to the next challenge. And the next challenge is called Heap 1. Okay. So this is another binary exploitation challenge, but this is the method of solving this one is very different from the previous one. So it says, can you control your overflow? Download the binary here, download the source here. Additional details will be available after launching your challenge instance. Okay, so to save a little bit of time, I'm going to supply the links for you in the chat. And then I'm going to go over to my web shell. This is heap 1. Heap 1, okay. So I'm going to have to make that directory. And I'm going to need to copy this stuff. Okay, and I'm going to make this this binary file executable, and then I'm going to nano into the C code. Okay, so this is a slightly more complicated version of the heap 0 challenge, and in the heap 0 challenge, what we were trying to do is we're trying to make sure that the contents of the safe var variable were not equal to its initial string, which was Pico with a B, I do believe. But in this one, it's checking to see if the value of the safe variable is equal to Pico, and if so, then we win and we get the contents of the flag. So let me demonstrate by going into the program. So for these type of challenges, we need to create a flag file. So I'm going to echo, we got the flag, and I'm going to echo that into a file called flag.txt, which is what it's looking for. And then we'll run the shell binary. Okay, and we have these same memory addresses that were similar to the ones in the last challenge, which was called heap 0. So between this memory address right here and this memory address right here, there are these two variables. So there's Pico, which is the initial value of the buffer that we can write, and there's Bico, which is the value of the safe var variable. So what we're trying to do is we're trying to overwrite the heap so that the value of the safe var variable doesn't say Bico, but it says Pico. And if you remember from the last challenge, the length of the buffer of the memory space between this address and this address should be 32 bytes. So what we need to do is we need to write 33 bytes. We need to write 32 bytes, and then we need to write Pico in order to fill up all the memory space between here to here, and then overwrite this with the value Pico. So we can do so by selecting 2, write to buffer, and then we have to supply some data for the buffer. So let me take a look at my notes. So it's heap 1. So this is what I have for the string that overwrites the buffer. So you see, we're overwriting the buffer from the memory address from here to over here with a bunch of different characters. There should be 32 characters right here, and then we overwrite with Pico, and that's going to overwrite this safe var variable with what it's looking for, which is Pico. So we're going to do that, and then we're going to print the safe var variable to make sure that we've overwritten it with the Pico value. So it's number 3. So safe var variable equals Pico, and then we're going to do number 4, print flag, because the program, inside the program it says if the safe var variable is equal to Pico, then when we print flag, we win. So we're going to do number 4. So it says you win, and we got the flag, which is the value that we put into the flag.txt text file. Okay, awesome. So let's do it for real now. So inside of the heap 1 challenge window, we can launch the instance, start the virtual machine, and it's going to say connect with the challenge instance here. So this is a netcat command, which is going to communicate with the server at this particular networking port. Copy that, and then in the web shell, we're going to paste in this command. And this is the exact program that we were testing with, except that it's on the server and it has the value of the actual flag. So once again, the safe var variable is equal to Pico, to Bico with a B, and we want to overwrite it with Pico. And we can use the same string that we used to overwrite in our test scenario with this one right here that writes 32 bytes and then Pico. So we confirm that, and then we print the safe var variable with number 3. It seems to have booted me out. Okay, I'm going to go back and do that again. So I'm going to write to buffer number 2, and then I'm going to paste in this, and then I'm going to print the savebar variable. Okay, so the savebar variable is now Pico, so now we should be able to print the flag number 4. So it says you win, and it gives us our flag over here. So we can copy this. And we can also exit out of the program with Control-C, and then we can go back to the challenge page and paste in the flag over here. Click on Submit Flag. And then we can give the challenge a thumbs up if we haven't already. Okay, so let's see. I think we have time for one more. We'll do one more challenge before we call it a night. And this is the binary search challenge right here. So this is another general skills challenge. So binary search, I'm going to provide the link. And it says, want to play a game? As you use more of the shell, you might be interested in how they work. Binary search is a classic algorithm used to find an item in a sorted list. Can you find the flag? You have 1,000 possibilities and only 10 guesses. Cybersecurity often has a huge amount of data to look through, from logs, vulnerability reports, and forensics. Practicing the fundamentals manually might help you in the future when you have to write your own tools. Okay, you can download the challenge file here. Okay, so we can download the challenge file here. I'm going to copy the link. I'll provide the link in the chat. We go to our web shell, and we will move into our binary search directory. We'll make a temporary directory to move into, and then I'll download the file and unzip the file. So we have to go to Home, CTF Player, Drop In, and this is the file, the program that we're dealing with. It's a guessing game script over here. We're going to cat it out. Okay, so it's going to generate a random number between 1 and 1,000, and we're trying to guess. Okay, so if we guess lower than the target, it's going to say higher, try again. If we guess higher than the target, it's going to say lower, try again. And if we guess the correct number, it's going to say congratulations, you guessed the correct number. Okay, so let's play the game. So I'm going to back out. And then inside of the challenge, we need to launch the instance. So click on Launch Instance. So we're going to try to SSH into this particular server, and we're going to use this particular password over here. So we need to copy this, and then in the web shell, paste it in. It's going to say continue connecting. We're going to answer yes. And then we need to provide the password, which we can copy over here. Copy that. Paste this in. Okay, I'm thinking of a number between 1 and 1,000. Enter your guess. So what we need to do is we need to divide 1,000 by 2. Which is 500, so our first guess should be 500. Okay, then it's going to say higher, try again. So which we know that it's between 500 and 1,000. So we're going to divide 500 by 2, which is 250, and we're going to go up to 750. So we're going to go lower, try again. So what we need to do is we need to divide So it's less than, so it's 500 minus 750, so that's 500, so that's 250, so we're going to go lower by 125. So it's 625. So it's lower than 625, so 500 minus 625 is 125. So 125, which means we're going to guess. Oh, I'm not very good at math. Okay. So it's lower than 625, so we're going to go lower by 75, which is 550. And it's still lower than that, so it's between 550 and 625. So it's 575. I'm gonna bust out the calculator for this. Hold on. I'm sorry for anybody who thought I was good at math. I'm not. Okay, so it's 625 minus 550, 75 divided by 2, and it's 37. So it's 550 minus 37. So it's 513. So I'm going to guess 513, and it's higher than 513. Okay. So what are we doing? So we're doing 550 minus 513. So it's 37 divided by 2. So it's 18. So it's 513 plus 18. So it's 531. It's still higher. Okay, so that's 531 minus 513, and then divide that by 2, so that's 9, so it's 540. So it's lower, so it's, let's see, so that's 540 minus 531, that's 9 divided by 2, that's 4. So it is lower by 4, so it's 536. It's still lower, okay, so we're getting close. So it's 540 minus 536 divided by 2 is 2, so it's 2 lower, so it's 534. Okay, and we got the correct flag, okay. So, good guess. All right, so we can copy this, and then we can go over to the PicoCTF challenge page, and we can submit this. You can submit this as a flag. Okay, so that was binary search, and we can click on the upvote button over here to rate it positive. Okay, so that's all that we're going to be solving today as far as PicoCTF 2024. The binary search challenge, I successfully solved it by writing a program to solve the challenge for me, but unfortunately, between the end of the challenge and now, it seems that the script doesn't quite work so well anymore. So I'm going to need to start debugging that in order to get it working again. But everybody, thank you very much for tuning in today. Thank you very much to our good friend GX000 who came by and provided color commentary, and our good friend VM Smith who came by to show support. But yeah, this the recording of this is probably going to be split up into multiple videos when I upload them over to YouTube, and that's going to be a lot easier to watch. But to everybody who participated live, thank you very much for coming and joining us. We're going to be streaming again next week on Monday, where we're going to be doing a regular HackerFrogs After School workshop. And in the next workshop, we're going to be dealing with SQL injection, but we're going to be doing two new types of SQL injection. We're going to be doing SQL Boolean-based injection and SQL time-based injection. So let's ask ChatGPT, what are these types of injection? So Boolean-based injection, the attacker exploits the application's behavior by sending SQL queries that result in a Boolean true-false condition. So the attacker can craft SQL queries in such a way that the application behaves differently depending on whether the injected condition is true or false. And in time-based injection, the attacker injects SQL queries that cause the database to delay its response if the injected condition is true. So basically, Boolean-based injection and time-based injection are both true or false ways of determining whether or not the injection is working. But in one case, the output comes back right away, and in the other case, there's a delay if the output is correct. So that's it's a bit complicated and a bit tedious, but we're going to work through it, and in order to understand what's going on. But there are automated tools out there that make Boolean-based injection and time-based injection a lot easier to handle. But yeah, that's going to be on Monday, and I hope everybody can join us for that. But until next time, have a great weekend, and we'll see you next time.